Okay, so torque is something that's generated by a force. So it's not a force itself, but a force creates it. It's dependent on more than just the force. So if you go back and take a look at this, so I put a force up here, and it's going to cause the object to want to rotate. And really, that's important. A torque is something that causes an object to want to rotate. Whether or not it can rotate will depend on how big the torque is. Think about if you're trying to unscrew a bolt or something, right? And you have this tiny little wussy wrench that you put on your bolt. Well, so you have your hand out here, and so you're putting this force on the bolt and creating a torque, but it's very possible that the torque isn't big enough to make the bolt move. Probably innately, common sense wise, you would be like, oh, I need a longer wrench. Because by using a longer wrench, your force is dependent on your muscle. It's not going to change. But the length of the distance over which you apply that force changes. And that's the other important factor in torque. So if you look up here, it should be obvious that if I put a force of 100 newtons this far away from the pivot point, then I can make it spin. But if I put it right down here next to the pivot point, it's not going to spin as easily because the distance that the force is away from the pivot point is smaller. This distance, which we call r, is often referred to as the lever arm. And it's why longer handled wrenches and screwdrivers make our life easier, especially those of us who are not totally endowed with huge upper body muscles. Okay, there was a great Big Bang episode where the four guys were in a van that had a flat tire, and they couldn't get the lug nuts off the wheel because none of them were strong enough. And so then they're like, oh, let's use a longer lever arm. So they get some kind of a pole and put it in the torque wrench. The torque wrench in your car is the one that has like four things this way. So they put a pole in it, and then Howard is like standing on the pole, jumping up and down, trying to get the lug nuts off. It still didn't work, but anyway. So torque is generated by a force applied over some distance. Applied over some distance from the pivot point. So there are actually three things that torque is dependent on. One is the force, one is the distance, and the other is the angle between the force and the distance. Because you should be able to see that if I were to apply my force down like this, I'm really not going to end up making anything move, right? So if this is my stick again, and I'm applying a force like upward, it's not going to cause this to rotate. So the R would be maybe here, but it's not going to rotate if this is the pivot point. So the three things that it's dependent upon is the force, the distance, which we call an R because really it's a radius, right? It's the radius of the circle that this thing would move in. And the third one is the angle between them. And for those of you inside between the R and the F, those of you in Science 12.2, you'll be happy to see this. Torque is a vector, and we get it by what's called cross-multiplying the R and the F. Now, those of you not in Science 12.2, you learned about dot multiplying last year when we did W is equal to F dot delta D. We multiplied two vectors together, and that was the same as multiplying their sizes together by cosine of the angle between them. Well, when we cross-multiply two vectors together, over here what you get out is always a scalar. But when you cross-multiply two vectors together, what you get out is always a vector. And it's the same as multiplying by the size of the two vectors and by the sine of the angle between them. So our equation for torque is just RF sine theta, where though this is a vector, and so we have to figure out its direction. And the way we figure out its direction, I need to take this off just because I'm going to put the force back this way. The way we figure out the direction is you lie your writing utensil along the thing that's going to rotate, in this case this stick, and then you push, hold it at the pivot point. I don't know if I can do this with one hand. Hold it at the pivot point and then push in the direction of the force, and this force is going that way, and so this force would make this stick rotate like this. That's clockwise. And so we define clockwise rotation as negative. I did not do this, so don't blame this on me. And counterclockwise rotation as positive torque. Okay, so negative torque, positive torque. And that will come into play as we go to do sum of the torques. So up here, this guy at the top would cause positive torque, but at the bottom, hold it at the pivot point, push in the direction of the force. Oh, it also causes, sorry, both of them cause clockwise torque. Both of them would be negative. Let me give you another example. A teeter-totter, a seesaw, right? One kid sitting on this end, one kid sitting on this end. FG1 is acting down here. FG2 is acting down here. This spot, the fulcrum, would be the pivot point. So hold at the pivot point. The first kid is making it rotate clockwise. The second kid, though, is making it rotate counterclockwise. So this one would be negative torque, this one would be positive torque, and then you would do some of the torques and look after the direction. But we'll get into that more tomorrow. For right now, I want you to use this equation. Oh, units. I forgot units. R is measured in meters. F is measured in newtons. Torque is a meter newton. That is not the same as a newton meter. A newton meter is what you get over here when you do work, and we call that a joule. But when you're cross-multiplying vectors, the order matters. And so we can't reorganize this and write it as a newton meter. We always write it as a meter newton, and it's the unit for torque. There's no other name for it. So the other piece of your homework is I would like you to go to page 490, if only I could see, 495, and try numbers 29 and 30. Okay? So potentially 4 questions. 495, those two, and they are pathetic. They're just filling in an R and F and a sine theta. Okay? These two, example 3, if you didn't do it already, example 4, and these two, and then work on your assignment, because it will be due the day of the test, which will either be Thursday or Friday. Okay? Have a good rest of the day.